we will talk about the dimensions of the physical quantities, then dimensional formula, then dimensional analysis, and checking the dimensional consistency of equations, and deducing relation among the physical quantities. This is a very important chapter, subtopic in this chapter, and let us understand one by one. Actually, in the beginning, I have talked about quant physical quantities, that is fundamental quantities, and those were length, mass, time, then of course temperature, then current, then substance mole, and then luminous intensity. Here its units were Kelvin, ampere, then mole, and then candela. And sorry, ammeter. Then it's now we will write how in dimensional analysis how they are represented. This is represented as L, M, time, K, ampere, mole, and then there's candela. This is represented as basically ampere. Then we talked about the derived physical quantities like force. This was nothing but M into A. It was nothing but kg meter per second square. So this force is represented in fundamental units like this. Now in dimensionally we can write it as M, L, and T. Now it is -2. This is the dimensional formula for a physical quantity, force. So suppose you are asked, what is the dimension of volume? Then you know volume is equal to R meter cube, or you can write it as, so this is the dimension of, so any physical quantity can be represented in this form: m to power a, L to power b, and time or c, and so on. Correct? So this is the dimension. This is the basically fundamental thing. What do you understand by dimension? Representing any physical quantity in terms of m, L, T, K, A, mole, candela, like that. You can represent any physical quantity. You can write down the formula. But this formula does not give you about anything about any constant if it is there. Correct? Like suppose force is equal to 1 upon 4 pi epsilon 0 q1 q2 upon r square. It will have these dimensions, but this is a constant. This will not give you any idea about this, but still, if you know any, if you know the dimensions of any physical quantity, roughly you can form the formula. Let us now further see how this is going to work. Now suppose you are asked to find out, you are asked to write the dimensional equation of dimensional equation of suppose volume. Then what will be the dimensional equation? It will be m0 L cube and T0. Velocity, velocity we know, meter per second. Then you can write it as m0 L1 T minus 1. Correct? You can write it as for the force. What is the dimensional equation? It is nothing but m L T minus 2. M0, sorry, here it is M1. So like that, You can represent any physical quantity formula in the dimension form. Correct? Now let us talk about dimensional homogeneity principle. Means whatever equation is there, like suppose you have an equation like this. This we have studied, this is a valid equation, but let us dimensionally check it. This, what is this? This is distance. Naturally, its dimension will be L. What is U? U is nothing but velocity. T is time plus here. What is acceleration? L T minus 2, and here again time. Now let us check whether this is dimensionally homogeneous or not. Here T minus 1 is there, here T is there, so this will cancel out. So what is remaining here? L. Here T square is there and T minus 2 is there, then again this will cancel out, and again this. So this is a dimensionally homogeneous equation. So all the equations, they should be dimensionally homogeneous. If they are not dimensionally homogeneous, that means then the equation is not correct. Now, suppose, let us see, let us find out dimensionally how we can find out any formula. But time, suppose time period is dependent on L, length of the string, gravitational, G, gravity, and suppose M. Then this must be equal to K, L, A, G, B, or M, C. Or dimensionally we can write it as L means L, A, G is nothing but acceleration, that is minus 2, B, and M is here C. T is here, you can write it as M 0, L 0, T 1. Here again, if we write it as, then L will be nothing but A plus B, T will be minus 2B, and m is nothing but c. If we equate the powers, then what we are getting? A plus B is equal to 0 minus 2B is equal to 1 and C is 0. Correct? So from here we can find out it is B is equal to minus 1 by 2 and A is equal to minus B, or we can write it as 1 by 2. Correct? So these are the values we have found out. Now let us put these values here. L 1 by 2, G minus 1 by 2 and M 0. This will give you K K root L upon G. And we know this formula as 2 pi root L upon G. So except the value of constant, you got the correct formula due to this dimensional analysis. Correct? So this is how you can find out the formulas, you can deduce the formulas. If you know your physical quantity is dependent on what fundamental quantity. Correct? So this was all about chapter units and measurement. I have tried to cover most of the things, almost all the things which have been given in your NCERT chapter, and this full lecture gives you the full course within this chapter. So revise. Whenever you want to revise, you have to see only this one video, and all your concepts, all your uh, concepts will be revised in one go if you understand it fully. So this was one first chapter. Now my next video will be the second chapter of NCERT physics subject. So till then, goodbye. If you like this video, please do subscribe my channel, and we are going to cover the full syllabus of physics starting from the chapter 1 to last, first for the 11th class and then for the 12th class. Thank you very much.